All right, section 4.4. We're still talking about triangles, and we're still going to talk about congruent triangles. But up to this point, let me put a triangle in here, make it a little bit bigger. And let's make another triangle. Let's copy and paste it. So if I copied and pasted it, what kind of triangles do we have here? Congruent triangles. Very good. And let's just call it ABC, lack of imagination, and DEF. All right. And let's go to another color here. Let's do blue. A little bit bigger. Okay. These triangles are congruent to each other. So what do you know about the triangles? Well, you know if I picked this up and stuck it right on top of here, I know all the corresponding angles are equal, correct? So look, I know that this angle is equal to this one. I know that angle B is equal to angle E, and I know that angle C is equal to angle F. All right, so I know that. Is that the only thing I know about these triangles? No. If I could take this and put it right on top of here, what else would be true? Got the three angles equal, what else would be true? The sides, right? This is exactly what we went over on last night's homework, basically. Okay, I'm just kind of leading you up into what we're going to do today. So that means that, let's say, this side is equal to this side right here, so BC equals EF. We know that AC would equal DF, and I also know that AB would equal DE. So I know, how many things do I know here? How many things do I know? How many things, equal things, do I know that's true? Eric, how many? You said it, didn't you? I thought you said it. 6. Okay, somebody said it. Right, there's 6 things right here. There's 6 different things. There's 3 angles that are equal, 3 pairs of angles, right, that are equal to each other, and there's 3 pairs of sides that are equal to each other. We good with that? So if we know all that stuff, what can we then say about these two triangles? We can say that they are what? Congruent. And we can write the congruent statement. So let's write it. Triangle ABC is congruent to, that's a weird squiggle, but it's okay. Triangle. Now watch, if I go ABC, what do I have to go over here? DEF. Look, I went from 1 angle to 2 to 3. Do you see it? 1 arc to 2 arcs to 3 arcs. I got to go 1 to 2 to 3 over here, so it has to go DEF. All right, because the A and the D are equal, the B and the E, the C and the F are equal to each other. So that's all old stuff. What we're going to do today is this. I'm going to show you, let's copy that again, drop this down, put it right here. Now, if I did this, now just that right there, I didn't tell you I copied or pasted anything. If you just have 2 triangles right there, can you say that they're congruent with that amount of information? No, you can't, all right? They might look like it, all right, but you can't just say, they look like it, so I think they are. No, you can't do that. You can only go by the information that's given. So up to this point, yesterday basically, up to this point, we had to show 6 different things that were equal on here. We had to show 3 corresponding angles, and we had to show 3 corresponding sides. But this lesson today is going to allow us to show something that's a little less than the 3 or 6 different things. Yes. Oh my gosh. Last one. You're the last one. Let's try it again. Let's go A, B, C, D, E, F again. All right. Again, I'm not being very imaginative today. Now here's a they actually call this a postulate. We've used that word before. Do you remember what the difference between a postulate and a theorem is? A postulate is something that what? That what? Well, okay, that's an okay way to say it. He said it's already proved. It actually is not proved. It's just accepted fact, okay? You don't have to prove it, okay? You're on the right track with that, but you don't have to prove it. It's just an accepted fact, all right? So this thing we're going to do right here is just an accepted fact that I really can't prove it, all right? I'm not going to prove it because I can't prove it, because it can't be proven. It can be shown, but that's different than proving it. So anyway, this is my first postulate. Look, watch what the postulate says. It says that if I have 1 pair of angles equal, is that enough to make this a congruent triangle? No, it's not, okay? Because look, just because this is equal to this, I could take this side, come way down here like this. I could take this. I could make it a completely different triangle. So just because one set of sides are equal does not mean that it's a congruent triangle. What about this? Is that enough to make it a congruent triangle? No, it's not, because watch this. I'll just show you. Let me ungroup it. I could do this. I could keep the length of this the same. Let me watch. I could keep the length of that the same. Did I change the length of it? No, I just twisted it around, didn't I? But look what happens. If I connect it to make a... Oops. Does this twist up? Let's try this again. Let's get rid of that. Let's delete it. Watch. We'll do this. Now look what I did. Now these two sides are still equal to these two sides, but are the triangles congruent to each other? No, they're not. So is that enough information just to know that this side is equal to this one's equal to this one? Is that enough to say that the triangles are congruent? No, because I could show you. I could keep these sides equal, and I could show you a triangle that's not congruent to this. So that's not enough. Let's go back to where we were, right there. Watch what else they tell you. They tell you that this side is equal to this side right here. Now, let's think about this. Can I do anything to this triangle? Can I do anything to this triangle right here to make it look different than this triangle and still keep all these sides equal to each other? No, I could take this, watch, if I took this side and like swung it around or made it shorter, it would make this one shorter than this, right? They wouldn't be congruent triangles. So there's no way that I could do anything to this to make it look different. Some people would say, well, I could like twist it around. Like, let me see if I can do this. There we go. Does that make it not congruent? No, it's still congruent, isn't it? It's just twisted around a little bit, but all the angles will still equal, all the sides would still equal, so it's still a congruent triangle. So that's really all I need. I don't even have to say anything about the angles in here. If all I show is that 3 sides of one triangle equals 3 sides of another triangle, that's enough to say that the triangles are congruent to each other. I don't even have to say anything about the angles. Okay, so that's kind of a cool thing, because before I had to show 6 different things. I had to show 3 corresponding sides and 3 corresponding angles that were equal to each other. Now all I have to do is show 3 corresponding sides. I don't have to say anything about the angles. Okay, this is enough. So this postulate says if I have 3 sides of one triangle equaling 3 sides of another triangle, that's all I need in order to say that these 2 triangles are congruent to each other. I don't even have to say anything about the angles. Okay? Does that make any sense to you? Before today, I had to show all 6 sides, I mean 6 parts, 3 sides and 3 angles. Today, with this postulate that they told us, all I got to do is show 3 parts equal to each other, just the 3 sides. And they give this a name. Since there's 3 sides, they call it the side, what do you think? Side, right, because 3 sides. Side postulate. I'll just shorten that to postulate. Now, we don't have to write the words side. They make it nice and easy for us. What do you think we could write it like? Yep, S, and then we call it a postulate. Okay? Now, watch. When we write it, we can write the 3 S's next to each other, but when we say it verbally, we don't say the SSS postulate. We say, what do you think? Side. I'll put that in quotation marks, okay? So when we say it, when we verbally say it, so I say, if I ask you, why are these triangles congruent to each other? You wouldn't say SSS postulate, you would say what? Side, right, exactly. Does that make sense? All right. So that's kind of cool, because now I can show these 2 triangles are congruent to each other without saying anything about the angles. But guess what's going to be true about the angles? If these 2 triangles are congruent, now I know, watch, that triangle ABC is congruent to triangle DEF. Since I know that's true, what do you think now I could probably say about the angles in here? I could say the angles match up too, right? So I could probably say that what? Angle A equals angle D. I could say that angle B equals angle E. And I could say that angle C equals angle F. Now, I didn't know that at the beginning, did I? I didn't know those angles were equal to each other. The only thing that I knew at the beginning was that these 3 sides were equal to these 3 sides. But that's enough. So the postulate says, okay, if I got 3 sides equal to 3 sides, then I've got congruent triangles. if the triangles are congruent, guess what's true about these corresponding angles? They're equal as well, aren't they? And we have a name for that. You ready for this one? Okay. Here's the statement. Let me still see the triangle. It's this. If we have corresponding parts. Now, what are the parts of the triangle? We talked about this yesterday. What are the parts of the triangle? There's two parts of a triangle. What are they? The angles and the sides. Good. The angles and the sides. So, if I have corresponding parts of congruent triangles, I'll write it all out. I'll show you a simple way to write it too. Just like we did the SSS thing, there's an easier way to write all this stuff. If I have corresponding parts of congruent triangles, look, these triangles are congruent now, aren't they? Because of the sides are equal. So that means that A is equal to D. That means B is equal to E, and it means C is equal to F. Why? That's the big reason, and you're going to have to show me why. It's because the corresponding parts of the congruent triangles, because I know they're congruent now, are congruent. Now, I taught out of another book that I used to say are equal, but this book says congruent, so we'll use that. Now, here's a little easier way to do this. I take these letters. The corresponding parts, I don't use a letter for of, but of congruent triangles, and I don't use a letter for the A for R, are what? Congruent. So here's what I say. Here's my reason. It's a lot shorter than writing all that stuff out. What do you think I say? C what? P, C, T, C. So that's what this means right here. C, P, C, T, C. There's a lot of C's in there, but two of them mean the same thing. One means something different. The first C means corresponding. Corresponding parts of congruent triangles are congruent. Okay? When do we use that? We only use that after I've said that the triangles are congruent to begin with. All right? If I know these triangles are congruent, and now I do, right? I know the triangles are congruent to each other. So if I know the triangles are congruent to each other, what can I say about the other stuff that I didn't know at the beginning? I can say that they're equal as well, right? Does that make sense? So if I know that the three sides are equal to the three sides, they tell me that those three sides equals these three sides right here, then I could say that the angles have got to be equal too. Because if the triangles are congruent, the corresponding angles, right, that's a part of a triangle, the corresponding angles of these congruent triangles, they've got to be congruent as well. Okay? So basically it's like this. It's like, what were we given? What did they tell us at the beginning of this problem? They said that the sides were equal, right? Let's list them. They said that line segment AB was equal to line segment DE. And then what else? Line segment AC was equal to line segment DF. They told us that. What else did they tell us? They told us that line segment BC is equal to line segment EF. All right, this was given. They told us that. We didn't have to figure that out on our own. They told us that all that stuff was true. So if they told us that stuff was true, then what could we say about the triangles? Then we could say that the triangles were congruent to each other. I've already written it up there, but I'll write it one more time. All right, so if all that stuff is true, then the triangles are congruent. Now, if the triangles are congruent to each other, what else could I say about the stuff inside the triangles? The angles are equal. Very good. So I could say that angle A equals angle D. They didn't tell us that to begin with, though, did they? All right, we came up with that after we knew that the triangles were congruent. So angle A would equal angle D. Angle B will equal angle E. And then angle what? C is equaling angle F. Everybody see that? They didn't tell us this. We only knew this because we know the triangles are congruent. And the reason, when we do these things, the reasons are very important. Okay, what is the reason? Why does angle A equal angle D? Why does angle B equal E? Why does C and F equal each other? Why? Why? Because of what? Got a reason. It's right there in front of you on the screen. CPCTC, that's right, because of corresponding parts of congruent triangles are equal. So why is that true? Because of CPCTC. Sometimes I shorthand it when I say it, and I just say why? Because of corresponding parts. And when I say that, people usually know what I'm talking about. So when I say, oh, because corresponding parts are equal, Okay, well, they have to be corresponding parts of congruent triangles, though, don't they? All right. So well, let's do one more. Okay, we're running a little short on time here. I'll do the same exact triangles just to make it a little easier. Here's another theorem. Oops, got all that junk in there. Oh, I know why, because I grouped it together. Let's get rid of some of this. And I'll tell you what, let's just get rid of all this. Let's copy and paste this again. All right. Now watch. Here's another thing they're going to do. They're going to go a different color this time. Instead of knowing that all three sides are equal, we'll name it the same thing, A, B, C, D, E, F. It's supposed to be a B right there. It's kind of weird looking, but all right. Watch this. This time they're going to give you one pair of sides, a second pair of sides, but they're not going to give you the third side. Watch what they're going to give you. They're going to give you an angle that's in between those two sides right there. That's what they tell you. That's what's given. All right? They tell you all that stuff. You didn't have to figure it out. But this is actually, I think it's a theorem. Let me double check on this. Could be a postulate. It is. It's another postulate. Okay, this is another postulate. But look what they give you. They give you a side, they give you an angle, and they give you another side. That's enough right there. I don't have to go any further. I don't even have to know that BC equals EF. That's all I need to know. And if that's all I know, I can say that, guess what? These two triangles are congruent to each other. Okay? That's all I had to know. I didn't have to know all 6 things. All I had to know was this, that I had a side, an angle, and a side. But notice where that angle is. What did I say? It's in between those two sides. We call this the included angle. Included angle. It means it's in between those two sides right there. It's not this angle down here. You follow me? Here's two sides and an angle, but that's not going to work for us. All right? I can only pick the angle that's in between the two equal sides. So guess what we're going to call this? I got a side. I've got an angle that's in between. Right. And I'm going to call it side angle side. Very good. And how do you think I'll write this? SAS. But I don't say SAS. What do I say? I say side angle side. And this is a postulate. We don't have to solve for it. Or not solve for it. Prove it. I'm sorry. We don't have to prove it. We just accept it as fact because they told us. Okay? It's side angle side. So now, let's take a look at this. Let's do this in a different color right here. If I know these two triangles are congruent, what else do you think might be true about the triangles? Now that I know they're congruent, now I know I can take this, put it right on top of this, and they're exactly the same. What else do you think I could say about the sides and the angles? What do you think now I could say about BC? That now it's congruent to what? To EF. Very good. I didn't know that at the beginning, though, did I? I know this now because I know the triangles are congruent. So now I know that these are equal to each other. What else do you think I could say about this? The other angles are equal, right? So angle B must equal what? Angle E, right? And then what else? Angle C has got to equal what? Angle F. Now the purple things right here, give me a reason. Why does angle B equal E? Why does line segment BC equal line segment EF? Why does angle C equal angle F? Why? No, it's not because of side angle side. It's because I've already shown the triangles are congruent to each other. Okay, say it. Somebody said it. CP, CTC. Because of corresponding parts. Okay? Now, you got to get this straight. Why are the triangles congruent to each other? No. Why are the triangles congruent to each other? Because of side angle side. Why are these segments, why are these parts of the triangle congruent to each other? Because of CPCTC. So you got to understand the reasonings. The side angle side and the side are reasons why a triangle is congruent. Okay? CPCTC is why the corresponding parts are equal to each other. Why are the two angles equal? Because they're corresponding parts. Why are these two segments equal? Because they're corresponding parts. Why is angle C equal angle F? Because they are corresponding parts. Why are the triangles congruent to each other? Because of side angle side. We don't say SAS, we say side angle side. Okay? Does that make any sense at all? All right. You're gonna this is weird stuff. This is not like your normal math stuff. All right, this is a lot different than what you're used to in a regular math class, but this is big time geometry right here. Okay. Well, I was going to give you worksheets.
We got projects we gotta work on.
No, that doesn't matter to me. Okay, I make my own decisions here, so don't try. I think what I'll do is I think we'll work on this tomorrow in class together, just to kind of get you an idea of what we're doing. So I won't give you any homework tonight. I'll give you some tomorrow though.